Hello everyone, and welcome to the High Seas Habitat on the Big Island of Hawaii. I'm here with Michaela Musilova, and she's the director of the High Seas Habitat. What is exactly this amazing place?
So the High Seas Habitat, as you can see the dome behind me, is an analog site where we simulate missions to the Moon and Mars. So people actually live inside this small dome behind me for up to a year, but the missions can be from several days to several months depending on the purpose of the mission. And we try to recreate conditions that would be like on the Moon or Mars as high fidelity as possible. So people have to be inside at all times. When you go outside, you wear a spacesuit. We try and get the best possible analog spacesuits as well, and we improve every mission, all the equipment, based on the feedback we get from every crew. So we're constantly trying to upgrade this place. And the research that is done here is again similar to what you would actually do on the Moon or Mars. For example, explore lava tubes, collect geological samples, do astrobiology research, things like that. And then some missions are more focused on this research aspect, so collecting relevant data. Others are more on the psychological aspect of how do you choose the right crew to live here for long periods of time without, getting into conflict or hurting themselves or something like that. So it really depends, and we're actually open to research of all types that will help humanity advance to actually going to the Moon and Mars and living there sustainably.
And both you and I have lived in the High Seas Habitat, and I was actually part of the very first crew to live here, and I lived here for 4 months, and I know that you've done multiple missions here. And what is unique about the High Seas Habitat is that it's completely run on solar energy. And so I want to talk a little bit about how, as a crew member who has lived in high seas, what was it like to live in a habitat that is dependent fully on solar energy and managing that energy during the mission?
It's actually quite a task sometimes, because normally you would think in Hawaii the weather's gorgeous and why would we even have to worry about not having enough energy? But actually here we're about 8,200 feet up high on the volcano, where the weather can change. Even now you can see around us it's not exactly the sunniest, happiest day in the world. And if you get multiple days in a row where the weather is bad or just cloudy, you're not getting enough energy, the solar panels are not providing enough energy to these battery cells that we have in the storage shed actually right behind us. And so it just means that we're not collecting enough energy. And if we're using too much in the habitat to doing work on our computers, or there's a treadmill in the habitat which uses energy too, or we're cooking a lot, all the machines in the kitchen take up a lot of energy, suddenly you could be running low, and that it becomes an issue. For example, first of all, you could just run out completely, but if it's in the wintertime and it gets really cold up here, you could just get really cold because the heating won't be going on. You might lose power entirely and have to be working in the dark. And so there's things definitely you have to take into consideration, and that's why we have to monitor our energy levels during the missions. So basically the way we do it is we keep track of how much energy is in the batteries that collect the solar power. And when we get to certain percentages, so for example, if we're getting close to 60%, then we know we need to be super careful, because we basically don't want to go under 40 overnight, because if we need heating, it could actually get down to very low numbers by the morning, and we would risk running out of energy. So that's when today's bad weather, we had bad weather yesterday, let's not use the treadmill today, or let's just cook with the minimum amount of appliances, things like that. But should things, despite the best efforts, which is what happened on one of my missions actually, we really cut down on all energy usage to the bare minimum. We were all sitting huddled in multiple amounts of clothes, and I think you went for a similar thing yourself. And despite all our best efforts, we still ran out of energy. That's why we have multiple backup plans. At the moment, we just have a generator. So that's basically, all you have to do is flip a switch and it goes from solar power to the generator. Of course, you wouldn't have that on the Moon or Mars. So the idea is it's kind of like a simulation of nuclear power, which again isn't ideal for humans. So what we really want as the next backup plan is to use hydrogen fuel cells. And so that's where it would switch to, from the solar panels to that. And the generator would be really the last resort if all else fails.
So when we talk about high seas and energy, this is really kind of looking at what we will be doing on the Moon and Mars, and testing some of the latest technology, especially when it comes to harnessing the power of the sun, but how we store that energy and basically bank it for when we don't have the sun shining.
Exactly. I mean, solar power has been used in the space industry for over 60 years now. The astronauts on the International Space Station are dependent on it. They use over tens of thousands of solar cells for all their activities. So it's crucial to the way space operations work nowadays, and it's probably not going to change. If anything, we're going to become even more dependent on it in the future, but we do need to have backup plans, especially with space missions. You cannot rely on having just one or two sources of energy or water or anything that's really crucial to the survival of a crew. So we will need to have backup plans, and exactly working on ways of storing that energy, having a different source or multiple different sources is definitely part of the research and something that we're testing here. So even the fact that there's just one switch we have to push or switch in case of loss of energy for the solar panels is something we learned along the way, where before it used to be a much more complicated system, and in an emergency you just don't want to be wasting time on that. So instead we just made it as straightforward as possible. And these are all learning lessons we're getting thanks to doing research here on a regular basis and collecting feedback every time.
Wow, that's really fantastic. Thank you for sharing all this with me.
Oh, you're welcome.